this is single positive charge, double positive charge. So all these are ions. Because they are positive, they are called cations. So example of anion is chlorine with negative charge. Non-metals are mostly anions. Non-metals are mostly anions. Non-metals are mostly negatively charged, whereas mostly positively charged. So these are the three discrete particles that matter is made up of. Subsequent classes, we are going to be going into details of how to use these and understand them. John Dalton in 1808 helped us understand more about atoms, and he put forward the Dalton's atomic theory. This Dalton atomic theory over the years have undergone several changes and modifications because some of the statements through experiments have been proven to be wrong or cannot hold completely. So now we're going to look at the statements of the Dalton atomic theory, and at the same time I'll be mentioning or pointing out the modification or the modifications that have been done on these statements. So let's look at the first statement of Dalton's atomic theory. All elements are made up of small, indivisible particles called atoms. Is this true? Yes, because all elements are actually made up of atoms, small atoms, but that these atoms are indivisible. Now, through the experiments of people like Rutherford, we're able to know that atoms are actually divisible. Atoms are actually made up of protons, neutrons, and electrons. So whereas the first part is true, the second part is not true. So this used to be very correct, but because of several experiments that have gone through in recent times, we are able to find out that atoms are actually divisible. Number two, atoms can neither be created nor destroyed. This still holds true for ordinary chemical reactions, but we know that in nuclear reactions, things like uranium can still be broken down into other atoms of other elements. Now, so this one, nuclear reactions, makes this very statement to be not completely true. Here, the discovery of electrons, protons, and neutrons made this not to be completely correct. So these are the modifications to this, whereas nuclear reactions should be taken into consideration for you to have this to be true. Now, thirdly, we have that atoms of the same element are alike in every aspect and differ from atoms of all other elements. This is not completely true because of the discovery of isotopes. Now, in isotopes, we find out that one element, say chlorine, can have different isotopes. They can have the same chemical property, but the mass number will not be the same. So this is the modification to this. Now, when atoms combine with other atoms, they do so in simple ratio. This is actually correct for inorganic reactions. The combination between the combining atoms, different atoms, for inorganic reaction can occur in simple ratios. But when you have complex organic reactions, like that involving proteins or other things in organic chemistry, there is no simple ratio combination. can have them in multiple ratios. Now we have the fifth statement of the Dalton atomic theory. All chemical changes result from the combination or separation of atoms. I think this still holds true. So these are the statements of the Dalton's atomic theory, and these are their modifications. So these modifications were born out of experiments that had been conducted since after Dalton in 1808. Since after John Dalton in 1808 put forward the following statements. Much of this statement has already been supported by things like the law of multiple proportion, the law of conservation of mass, and other laws. So in subsequent classes, we are going to do a lot of calculation and other inferences. Thank you. Let's look at symbols of elements. Now, if you want to represent an element, maybe in a chemical equation, or if you want to write it in abbreviated form, and you want people to understand, you use what we call symbols of elements. Symbols of elements are simply the first letters. If the first letter is already taken, you can have the first letter plus the second letter as the symbol of an element. Now you can also have the first letter of the Latin version of that element, or the Latin name of the element, or the first letter of the Latin element and the second letter. So that is how we come about symbols of elements. So we're going to be looking at the first 20 elements and their symbols. Now let's look at element number 1, hydrogen. The first letter is H, so the symbol we are using H. Element number 2 is helium. Because H is already taken and it's also the first letter, now we use the first letter plus the second letter. So we have He as the element, as the symbol of helium. Lithium, we have Li. Beryllium, we have Be, because we already have boron as B. Carbon is C. Nitrogen is N. Oxygen is O. Fluorine is F. Neon is N. Sodium is N. Why is sodium N? Because the Latin name for sodium is natrium. So we are using this first two. Na. Sodium is Na. Sodium is Na because the Latin name is natrium. So we are using it as a symbol. Magnesium is Mg. Aluminium is Al. Silicon is Si. So the symbol can either be the first letter or the first letter plus the second letter. Hello, welcome. Let's continue with the first 20 elements and how we can memorize them and be able to use them. So we have the atomic numbers, which is increasing downwards, and we have the elements. We have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, with atomic number 14. Then we have phosphorus, sulfur, chlorine, argon, potassium, and calcium. So from 1 down to 20, I continued from here because of the space. So these are their symbols, and like I taught us in the last class, symbols are just the first letter of the name. It could be the Latin form of the name, like sodium. The Latin name is natrium, so the symbol is Na, the first letter with the next letter. So it could be for the English name or the Latin name, the first letter. And if the first letter is already chosen, the first letter and the second letter, the first one written in capital letter. So that's how you represent the symbol. Now, we are going to look at atomicity and atomic number. Like these are the atomic numbers of these very elements. So starting from 1 down. Now, atomicity simply means the number of atoms in the molecule of a given element. So let's say we have H2. This is how the molecule of hydrogen is. So what is the atomicity of this? The atomicity is actually 2, because there are 2 atoms of hydrogen in this very molecule. If you have ozone, O3, the atomicity is actually 3, because there are 3 atoms of oxygen in ozone. So that is what atomicity is. Now, let's look at how we can memorize the atomic numbers of these first 20 elements. Now, when I was in school, there is this method that I used, and I would encourage us to devise a way, because knowing the first 20 elements and the atomic number will help you in a lot of calculations in basic chemistry, because you're supposed to know the atomic number. And you can easily infer the mass number with the atomic number, because most times the mass number is actually the atomic number times 2, with some little difference or fractions of difference. So how do we memorize the first 20 elements? So this is how I got around it when I was in the secondary school. So this is the elements themselves with their atomic numbers. So the way I do is that once I get into the hall, or when I want to work extensively with calculations involving atomic number, mass number, valency, oxidation number, and the rest of them. So I go with this song. Hello, Helene. Hello, representing hydrogen. Helene, representing Helen. But I'll go through it. Hello, Helene. Listen, Helene. Boron cannot overflow neon. So may all silly people sulfur, chlorine, argon, potassium, calcium. So that's the way I used to memorize the first 20 elements, which I would like you to look at. So let's go through it again. Listen, Berlin. Boron cannot overflow neon. Hello, Helene. Listen, Berlin. Boron cannot overflow neon. So may all silly people for phosphorus, sulfur, chlorine, argon, potassium, calcium. So this was what I was taught when I was much younger, and it really helped me a lot in trying to memorize the first 20 elements so that I can easily deduce their atomic numbers and also infer their mass numbers and use those in calculations. So I would like you to look at this very critically. Now we also looked at the symbols of elements and also atomicity. Atomic number, like I told you, are these numbers. So for hydrogen, the atomic number is 1. For helium, the atomic number is 2. For lithium, the atomic number is 3. Just like that. So up to silicon, that is 14. Phosphorus is 15. Sulfur is 16. Chlorine is 17. Argon is 18. Potassium is 19. Calcium is 20. So these are the first 20 elements, and these are their symbols. So atomicity is simply the number of atoms in one molecule. Molecule S8. The atomicity is 8 because there are 8 atoms of sulfur in this very molecule. If you have this molecule P4, the atomicity is 4. Now looking at the subscript, the number subscript to the symbol of the very element. So that's where we're going to be stopping today. In subsequent classes, we're going to be moving further. Please hit the subscribe button to subscribe. And please, thank you, and God bless you.